We're going to be taking a look at some more antiderivative rules today. We're going to look at, well, actually, the rest of these are going to be non-power functions, meaning it's not just an x squared or an x cubed. It's a little bit more complex than that. Let's go ahead and take a look at what I like to call rule number 6. I looked at 5 rules. This is our 6th rule, and this is the 1 over x rule. So I guess you could say this is a power function in the fact that it does have an exponent of -1, but it's not a whole number, right? So anyway, this rule applies to 1 over x, and if you take the antiderivative of 1 over x, okay, and again, you could say the integral, but we'll talk more about what integral means later. If you take the antiderivative of 1 over x, you get natural log of absolute value of x plus c. Remember to always put the plus c, just because the derivative of c is 0, you would get 1 over x back. Now, why is this true? Well, we've looked at the rule already for the derivative of natural log of x is 1 over x, so it makes sense that the reverse is true. But why the absolute value? Well, if you remember what the graph of ln of x looked like, it looks like this. Okay. So if you tried to plug in a negative number, a negative x, it wouldn't exist, right? So we have to put the absolute value bars there because to make the domain work. In other words, you can't plug in a negative into natural log because you would get undefined. That's why the absolute value bars are there. So another way of writing 1 over x is x to the -1, right? These are the same, and therefore their antiderivatives are the same. All right, let's take a look at an example. We have evaluate the antiderivative of 2 minus x cubed all over x dx. Don't forget your dx. I've said that before. That just means in terms of x. And I always go back again to the definition of the derivative, that h on the bottom, limit as h approaches 0. That's basically what your dx is. It's your change in x, which is infinitely small. So how do we take the antiderivative of this? Well, you might be thinking, well, why? How does this apply to the 1 over x? Well, that's what we're going to talk about. I'm going to go over some steps with you for these antiderivatives. 4 simple steps. The first step is to convert to antidifferentiable form. So if you just try to take the antiderivative without simplifying this, it's not going to work out too well. But what we can do, since there's just one term in the bottom, is we can divide both of these terms on top by that x on the bottom. That will simplify to 2 over x minus x squared. Now this on the left is looking more like 1 over x, right? So what we can do is pull this 2 out, put it out front. It will be 2 times the antiderivative of 1 over x dx. And we can split it up into 2 antiderivatives. We talked about that before. That's the difference rule for antiderivatives. We can just split them up into 2, and now it's minus the antiderivative of x squared. So we have 2 times the antiderivative of 1 over x minus the antiderivative of x squared. We can take the difference of these 2 antiderivatives, and we can use our constant multiple rule right here, meaning we can take the antiderivative of this and then multiply by 2. And then, of course, we can take the antiderivative of that because that's a simple power function. So let's go ahead and do that. For step 2, we're going to antidifferentiate, and we will be applying the rule we just learned. The antiderivative of 1 over x is natural log of absolute value of x. We'll just tack the 2 on to that because that's a constant multiple rule, and then we can subtract the antiderivative of this, which would be x cubed over 3, or 1/3 x cubed. Don't forget your plus c. So we put all that together, and we get 2 natural log of absolute value of x minus 1/3 x cubed plus c. And, from there, we want to move on to step 3, which is to see if there's anything we can do to simplify that. And it doesn't look like you really can. I didn't really see this before, but you could actually move this 2 and just call that natural log of x squared. That goes back to our log rule. Now, why does that work? Because, if you plugged in a negative x and you squared it, it would still become positive, so you could just go ahead and take the absolute value bars away. Pretty cool stuff. So you could convert that to that if you wanted to, or you could just leave it that way. They mean the same thing. Okay, so this and this mean the same. So step 3 is to simplify, and Like I said, you can either do that or leave it the way it was, whichever you prefer. Step 4 is to check by differentiating. So fortunately, there's an easy way to check the antiderivative. Just take the derivative of your answer. So we're going to take the derivative of this. Derivative natural log of absolute of x is 1 over x, and then just tack the 2 onto it. Take the derivative of this. Anyway, I'm not going to go over all of this, but you can see that when you take the derivative, you get the original function back, 2 minus x cubed over x. So that's it for example 1 and applying the antiderivative of 1 over x rule. If you have any other questions about this, let me know.